Hi, Assalamualaikum. My name is Durratul binti Nordin and my matrix number is 77931. For this subject, KN R1042, Measurement and Instrumentation, and my lecturer name is Mr. Hazmi Hijazi. Today, I will present about mini project experiment. For this circuit, it's contain one power supply which is 1.5 volt, 3 resistor, 1 kilo ohm resistor, resistor R1 and 2 is connected in series. Meanwhile, resistor 2 and resistor 3 connected in parallel. And now we need to find the theoretical value. To find the total voltage is equal to 1 volt plus 0.5 volt is equal to 1.5 volt. To find R23, R2 is parallel with R3. So equal to 1 times 1 over 1 plus 0.5 is equal to 0.5 kilo ohms. To find the V1 is equal to R1 over R1 plus R2 at R23 times with Vs. Vs is total voltage. So equal to 1 times 1 over 1 plus 0.5 times 1.5 is equal to 1 volt. To find V2 is equal to R23 over R1 plus R23 times V Vs is equal to 0.5 over 1 plus 0.5 times 1.5 is equal to 0.5 volt, and the value of V2 and V3 is the same, which is 0.5 volt. To find the total current equal to I1, which is 1 milliampere. I1 is equal to Is is and equal to Vs over R, equal to 1.5 over 1.5 times 1 and equal to 1 milliampere. For I2 is equal to 1 over 2 times 1 equal to 0.5 milliampere, and for I3 is equal to 1 over 2 times 1 and equal to 0.5 milliampere, and the value for I2 and I3 is the same, which is 0.5 milliampere.
To break this circuit, we need a breadboard, 3 1k ohm resistor and 1.5 volt battery. So for the R1, we put one resistor here across in one line. For R2, we put it here and R3, we put it at the same line as R2. For the power supply, we put the negative terminal here in the beginning of the R1 and the positive terminal here at the end of R2. To measure the total voltage, we need to put here at the R1 at the end at the R2. So we get 1.608 for the partial voltage. For the R1, we put at the R1 slot here. .073 for the R2 here. 0.535, and for the R3 0.535. To measure the total current, first we need to take out the negative terminal of power supply. Then we measure it here, and the other one at the feed of the R1, and we get 1.016 milliampere. That is for the total current. Now we're going to measure the current for each resistor. For the first resistor, there is R1. We take this one feed out, we put it away. When we take one breadboard wire, we put at the first place, then we measure this here and here. And we get 1.035. That is for the R1. For the R2, we take one feed out, then we put the wire at the first slot, then we measure. We put it here and here. We get 0.513. And for the R3, we do the same thing as the R2. Put it here, then we measure it here and here. And we get 0.515, and that is how we measure the current through each resistor.
And now we want to compare the theoretical value and the measured value. For the partial voltage for R1, the theoretical value is 1.0, meanwhile the measured value is 1.07. And for R2 is 0.5, meanwhile the measured is 0.53. For the R3, the theoretical value is 0.5, meanwhile the measured value is 0.53. For the partial current, for the R1, the theoretical value is 1.0. For the measured value is 1.04. For R2, the theoretical value is 0.5, meanwhile the measured value is 0.51. And for R3, the theoretical value is 0.50 and the measured value is 0.52. For the total voltage, for the R1, in the theoretical value, we get 1.5, meanwhile for measured value is 1.6. And it's the same as R2 and R3. For the total current, for the all three resistors, for the theoretical value is 1.0, meanwhile for measured value is 1.02. From this, we can see theoretical value and measured value is slightly different, which is measured value is slightly higher than theoretical value. For discussion, in this experiment, a series parallel circuit of 3 resistors was conducted. A 1.5 volt voltage source was used, and all the 3 resistors are 1 kilo ohm resistor. After the circuit was constructed, I measured the total voltage. The measurement total voltage was 1.06 volt. Then I measured the partial voltage for each resistor. The partial voltage for R1, R2, and R3 were 1.07 volt, 0.53 volt, and 0.53 volt respectively. Meanwhile, for theoretical values was slightly lower then measured values, which is 1.0 volt, 0.5 volt, and 0.5 volt. The total of the measured partial voltage is 1.5 volt. Since R2 and R3 were connected in parallel, the partial voltage is the same. This verified the Kirchhoff voltage law, where the algebraic sum of partial voltage should be 0, which is negative 1.6 volt plus 1.07 volt plus 0.53 volt is equal to 0. Next, I measured the current of the circuit, and the total current measured was 1.02 milliampere. Then I measured the partial current for each resistor. The measured partial current for R1, R2, and R3 was 1.04 milliampere, 0.51 milliampere, and 0.52 milliampere respectively. Meanwhile, for theoretical values was slightly lower than measured value, which is 1.0 milliampere, 0.5 milliampere, and 0.5 milliampere. The value of total current and partial current for R1 was supposed to be same, but my measured value has an error and make it 0.02 milliampere different. The sum of partial current of R2 and R3 should be same as total current and partial current for R1 to follow current division rule, but my measurement value was 1.03 milliampere, which is between the total value and the partial current for R1. The value was slightly different when comparing theoretical and measured value. This is due to component tolerance, such as resistor tolerance. The resistors has a tolerance of 5%. In conclusion, knowledge of operating a multimeter is very important to an electrician. Understanding how to use a multimeter for testing and troubleshooting is undoubtedly a useful skill for electrical engineering students and engineers. During this experiment, we were able to measure partial voltage, partial current, the sum of voltage and current. In addition, the components and tools provided could be used to set up electrical and electronic experiments according to specific requirements. This knowledge will certainly be very useful in future laboratories. And that's all for me today to explain this mini project experiment. Thank you.